Hello and welcome to the Great Conjunction live stream, hosted by the University of Exeter Astrophysics Group and the Exeter Science Centre. Thanks so much for joining. Today we are celebrating a once-in-a-lifetime opportunity to see Jupiter and Saturn closer together in the sky than they have appeared for 400 years. They are visible in the same field of view of a single telescope, which is such a rare and exciting event. And we're really hoping for some good gaps in the clouds to be able to share this event with you. I'm Dr. Alice Mills, co-founder and co-director of the Exeter Science Centre, working to create a STEM Discovery Centre in Exeter. I'll be presenting the live stream this evening alongside Dr. Natalie Whitehead.
Hi, I'm Dr. Natalie Whitehead, co-founder and co-director of the Exeter Science Centre. As Alice said, this is a really rare event. The Great Conjunction itself is on the 21st of December, when the planets are at their closest, but any time between now and the 23rd, these planets should be visible in the same field of view of a telescope. So hopefully you'll have lots of opportunities to see this for yourself, weather permitting. Let's start by introducing everyone tonight. Behind the scenes, we have our tech expert, Dr. Sam Morell, making sure that you're all seeing what you should be seeing. Adrian Uja will be monitoring the questions coming in from YouTube, answering some of them and sending the others to the relevant experts. At the telescope, we have Dr. Stephen Reeder, a postdoctoral researcher in astrophysics, and we have the head of astrophysics at the University of Exeter, Professor Matthew Bate, with tech support from Dr. Chris Brunt. They are currently on the roof of the physics building with their telescope ready to show you this fantastic event up close. Matthew and Stephen, can you introduce yourself and tell us how's it looking over there?
Okay, thank you very much, Natalie. So hi everyone, I'm Professor Matthew Bate. You can see here we have a telescope. This is Stephen Reeder here as well. We're on the roof, we're ready to go. Unfortunately, the weather's not cooperating very much at the moment. We've got an enormous bank of cloud over us right now. We're hoping it might clear in the next 30 minutes or so, but we'll just have to see what happens over the next half hour and make a call. Yeah, do you want to say anything, Stephen, at this point?
Well, at this point, nothing else to add, really. We have been able to see Jupiter and Saturn earlier this week with the telescope. So it's all looking good, except the weather is, well, it started raining right now, so not great.
Yeah, so I think we'll hand back to you for the moment, Alice and Natalie.
Okay, thank you for that, Matthew and Stephen. Well, we really hope we get to see it. We are also really lucky to be joined by a whole panel of astrophysics experts from the University of Exeter today, ready to answer your questions. They'll all introduce themselves now. So firstly, Dr. Jenny Hatchell, who is a lecturer in astrophysics.
Hi, I'm Dr. Jenny Hatchell, and as well as lecturing, I specialise in studying the early stages of star formation. Today, I'm going to be showing you a model that you can try at home to understand why we're observing a conjunction and why we don't see them very often.
Great, thanks, Jenny. So lots of you have already sent in questions, which we'll ask our experts through the show today. But if you have any extras, we've got Adrian monitoring your comments, so do get in touch. Now I'd like to introduce Dr. Sebastian Kreit, a lecturer in astrophysics.
Hi everyone, my name is Sebastian. I'm a new lecturer here in the Astrophysics Group at the University of Exeter, and I work on all kinds of things related to planet formation. So I'm joining you live today from my son's desk here in our living room, and I'll try to answer any questions you may have about the formation of planets, both in our own solar system and beyond.
Thanks, Sebastian, that's great. Now we'd like to introduce Professor Nathan Main, Professor of Astrophysics and Planetary Climates.
Thanks, Alice. Hey, everyone. I'm Nathan, and my research focuses on the climates of planets, and in particular, trying to understand the climates of planets we've found orbiting distant stars that we call exoplanets, trying to understand really if any of those are potentially habitable and do host life, perhaps, but also trying to use that knowledge to help understand planets closer to home, like Jupiter and Saturn, and even Earth.
Great, thanks Nathan. So next on our panel of experts, we've got Dr. Stephen Thompson, who's a lecturer in the mathematics department at the University of Exeter.
Hi, thanks Alice. So yes, my name is Dr. Stephen Thompson and my research focuses on the weather and climate, particularly on giant planets in our solar system, particularly Jupiter and Saturn, but also terrestrial planets like Earth and Mars. And I mainly focus, as you said, on the mathematics behind the weather on these planets and how we can represent this weather using computers.
Thanks, Stephen. Finally on our panel, we have Federica Rochinho, a PhD student in the Astrophysics Group. Hi, Federica.
Hi, everyone. I'm Federica, and I'm just starting my PhD in exoplanetology here at Exeter. I've personally focused on studying and better understanding stellar activity to allow for the detection of small Earth-like planets, and I'll be around to answer questions, and in particular to get the younger crowd interested in astronomy.
Thanks, Federica. What a great panel we've got. So we have got lots of excellent questions for you all later, but let's go back to Matthew and Stephen quickly and just see if we can get anything from the telescopes yet. Matthew and Stephen, how are you doing?
We're fine. It's still raining here. So I'm going to hand over to Stephen. He can tell you a little bit about the equipment that we've got here today.
Hello, everyone. So while we were waiting for skies to clear up, let me just tell you a little bit about the telescope. So this is the telescope that we're using. There's a camera at the eyepiece. And apart from that, it's just a large mirror here at the back end, collecting a lot of light, reflecting it back to the front end towards the camera. So what it's doing, it's both collecting a lot more light than you would normally see with your naked eye, and it's also magnifying that. So this is a Newtonian telescope invented by Isaac Newton, one of the things he's famous for. And it's one of the better types of telescope for this kind of thing. It's on an equatorial mount, which means that the axis here is pointed towards the polar star, the North Polar Star, and it's counter-rotating against the Earth's rotation. And the benefit of that is that when the Earth rotates, and we see the planets move in the sky, this telescope also rotates, so they stay in the same field of view. So for these kind of observations, it's perfect. The one thing it can't do, unfortunately, is look through the clouds. So we'll have to see. Back to you.
Great, thank you very much, Stephen. So I believe now we're going to watch a very quick video which shows you what we should be seeing if, fingers crossed, the clouds clear up for us.
What have Jupiter and Saturn looked like over the past 2 weeks? Stephen Reeder and myself, Matthew Bate, have captured photos and videos on clear nights, some of which I'm going to show you now. This photo was taken with the camera on December the 8th. You can see Saturn in the top left and Jupiter and the 4 Galilean moons that were discovered by Galileo in the bottom right. Jupiter and Saturn were approximately 3 lunar diameters apart at the time. Tonight they'll be 6 times closer, just half the diameter of the moon apart. Here I zoom up on Jupiter and its 4 largest moons. Although you can't see any detail for Jupiter and Saturn themselves, a camera with a long focal length lens can capture the Galilean satellites. Here's a short movie taken using Stephen's telescope on December the 8th. You can see that Saturn is oval in shape because of its rings, and again you can see Jupiter's moons. The telescope has a focal length more than 3 times longer than my camera lens, so it provides much higher resolution images. This allows Saturn's rings to be seen, although we're still dependent on the atmosphere being relatively still, otherwise it distorts the image. The fact that the Great Conjunction is only visible near the horizon means we're looking through a lot of atmosphere, so you shouldn't expect very sharp images of Jupiter and Saturn themselves tonight. Regardless of what we see tonight, don't forget to try to see the Great Conjunction yourself, simply using your eyes. I took this photo over Exeter on December 12th. Jupiter and Saturn were about 4 times further apart than they will be tonight. This is what Saturn looked like on December the 12th. Note that the upper part looks blue while the lower part looks red. This is because blue light is refracted more than red light as it passes through the atmosphere. This effect gets stronger as Saturn gets closer to the horizon, so you may see it again tonight. On December 15th, Jupiter was noticeably closer to Saturn, and again you could see all 4 Galilean moons, but in a different order than they were on December the 8th. Here I've combined 2 different photos with different exposures to allow you to see Saturn's yellow colour and the 4 Galilean moons at the same time. Here's another photo of Saturn and Jupiter over Exeter, this time on December the 14th. You'll notice Saturn is significantly fainter than Jupiter. I think it makes a lovely Christmas photo. So, if it's clear tonight, what might we expect to see? Jupiter and Saturn are now much closer than the photos you've just seen. Hopefully we'll be able to see Saturn's rings and Jupiter's moons simultaneously. But only 3 of Jupiter's moons are visible tonight because Io is behind Jupiter at the moment. We may also be able to see Saturn's largest moon, Titan. Jupiter and Saturn will be at their closest to each other about 48 hours from now, with about half the separation they have tonight. We don't have long to observe Jupiter and Saturn tonight. Even if the sky is clear, they're slowly sinking towards the horizon and will set around 6:15 p.m. Let's hope for clear skies tonight.
Fantastic. So hopefully we'll get some clear skies, but we'll pass back to the astrophysicists in a moment to see. But first of all, we've had lots of questions sent through on our webpage already. And so I'm going to be speaking to Sebastian first to answer a few of them. So we've had quite a few questions, Sebastian, asking whether the alignment of the 2 biggest planets in our solar system, Jupiter and Saturn, will have any gravitational effect on the Earth.
Yeah, thanks, Natalie. Well, fortunately, no. So even though these planets are massive, right? They're like 318 and 95 times as massive as the Earth. They are also really far away. And this makes their gravitational influence here quite small. So for example, you can calculate the gravitational pull of Jupiter or Saturn on this little bus here and compare it to the gravity the Earth is exerting on it. If you do this for Jupiter around this week, you found that the force exerted by Jupiter is something like 60 million times weaker than the force that the Earth has. And then Saturn's is another factor of 10 below. And even the force with which the Earth is pulling is not all that strong, right? The entire Earth is pulling down on this bus, but I can just use my hand to sort of move it around. And I haven't worked out in quite a while. So really, I think if you feel a little bit off this week, don't blame Jupiter or Saturn. It's more likely to have been something that you ate or drank.
That's good to hear. Thanks, Sebastian. We've also had some questions from Leanne, Jan, Manny, and Steve, all asking whether conjunctions of many planets or even all the planets have ever occurred or will ever occur. How about that one?
Yeah, it's a very good question. So the orbits of the 8 planets, or 9 if you count Pluto, I certainly do, don't lie exactly in the same plane. And this makes perfect alignments between all of them extremely unlikely. I don't think it has ever occurred, but if you know of an event like that, please let us know and send us a message. Sometimes though, multiple planets will align in the sky, right? So tonight we'll have 2, but sometimes you have more. So for example, there was a morning, I think in March of the year 185 BC, where the 5 planets that you can see with the naked eye, so that's Mercury, Venus, Mars, Jupiter and Saturn, they all appeared within like 7 degrees of each other in the sky. And 7 degrees is quite small. If you make a fist and extend your arm, it's more or less the size of your fist there. And there's actually some evidence that the Babylonians saw this event and wrote about it. So it's quite interesting. But events like that are quite rare. I think they happen maybe once every 500 or 1,000 years. Yeah, and by the way, keeping track of where all the planets are is a very important thing to do, not just if you're interested in conjunctions. For example, in the 60s, scientists at NASA realized that the outer planets, so Jupiter, Saturn, Uranus, and Neptune, were all quite close together in the sky. And that meant that it was relatively easy to send 1 or 2 spacecraft to all of them just with one go. This led eventually to the launch of Voyager 1 and Voyager 2 in the 70s.
Brilliant, thanks Sebastian. So remember, you can get involved at home by posting on the YouTube comments, but we'll try to get through many of those questions as we can. So we've had a question from Harry, aged 8 in Barnstaple. How far apart will Jupiter and Saturn be? Now let's check back in with Matthew and Stephen at the telescope to find out.
Hi guys. Okay, so we've decided that we're going to call it off for today. We think that this cloud is not going to clear for at least another 3/4 of an hour. So essentially, rather than keeping you here using up your evening waiting for us and potentially nothing happens, we've looked at the weather forecast for tomorrow and it's looking quite good at the moment. So what we're going to do is advise you all to come back basically in 24 hours time, and we're going to try again. Okay, so we've got a lot of your questions that we haven't answered, and we will work through those tomorrow or whenever we get another chance. But basically we're aiming for tomorrow at this time. So please join us again then. Stephen and I are going to stay here. We're going to stay here essentially until Jupiter and Saturn have set. If we are able to get some images, then we'll be able to show you those tomorrow as well. So that's what's happening at the moment. Sorry about this, but that's what happens when you live in the United Kingdom and you try to observe things in the middle of winter. So I guess it's bye from us.
Matthew, perhaps just before you go, disappointing as that is, we have had a question from YouTube that might be relevant. Would the planets and moons be visible through the clouds via an infrared, microwave or radio telescope?
Right, that's an excellent question. And in fact, we have a radio astronomer right here. So I'm going to pass that one over to Chris. Chris, by the way, did not want to come on the video. So here is Chris, but he's an expert to answer that. Go ahead, Chris.
It would, yes. So if with the radio telescope, you would be able to see them, but it would have to be a pretty big one, usually, to be able to make out which one was which, especially given that they're so close at the moment. You would need something that was probably several kilometers across.
All right, so radio would work. Infrared, no, that would be no good at all. You'd just see a lot of cloud, I'm afraid. But yeah, radio is one thing that's not very dependent on the weather. Unfortunately, we haven't got Chris on his radio telescope today, although he does have an infrared camera, which he was hoping to show you later. Ideally, we'll show you that tomorrow. Over to you again, Alice and Natalie.
Okay, thank you so much, Matthew. And sorry to hear that the weather has not been kind, but this is often the way with trying to stargaze in England. So thank you so much, all of you, for watching so far. Hopefully you're all free to tune in again tomorrow when we're going to try this again. So if you'd like any updates to find out when we're going to be doing it, please do go onto the Jupiter Saturn 2020.org website and you'll find all the information you need there. We do apologise that we can't see it today, but there'll be the same experts here tomorrow ready to answer your questions and hopefully some gaps in the clouds to actually see this wonderful conjunction. And if we do observe it tomorrow, it'll be even closer to the date of the closest pass of Jupiter and Saturn. So it might be an even better time to see it. So I think we'll sign off for now, but thank you all for watching and hopefully we'll see you all tomorrow.